Hello there, and welcome to Science for Sleep, where the cosmos curls up beside you and science tucks you in gently beneath a blanket of stars. Tonight, we're drifting into one of the most powerful and perplexing mysteries in the known universe. A place where light disappears, time folds, and the laws of physics begin to whisper strange and ancient secrets. We're talking about black holes. Not the kind you might imagine in cartoons, vacuuming up galaxies like cosmic Roombas. Though, honestly, that image isn't entirely wrong. Black holes are real. They exist, and they're unlike anything else we've ever discovered. Some scientists call them one-way doors to the unknown. Others suggest they might be the engines of reality itself, or the delete key on the universe's keyboard. Tonight we won't shout these questions into the void. We'll whisper them. What is a black hole? Where do they lead? And is it even remotely possible that they could one day erase everything we know? But before we fall too deep into the gravitational pull of that idea, let me ask, where are you tonight? What time is it where you are? Maybe it's early, maybe it's late. Maybe you're lying in bed with one foot tangled in the covers, listening to the hum of your own breathing. Maybe you're just hoping sleep will find you soon. If this little voyage into wonder feels like the right kind of quiet, I'd be ever so grateful if you gave it a like or subscribed, or even shared it with someone who might need a soft place to land tonight. Now, I do hope this isn't so fascinating that it keeps you awake, but if it does, well, at least you'll be lying in the dark thinking about the strange beauty of collapsing stars, so settle in, slow your thoughts, and let's begin. Because somewhere beyond the edge of light, between the silence of space and the flicker of thought, lies the shadowy secret of black holes. We've all felt it, haven't we? That peculiar pull, that strange sensation of something vast brushing against the edge of our thoughts. A quiet awe, a subtle shiver, a sense that somewhere out there, far beyond the moon and weather and headlines, lies something watching, not with eyes, not with intention, just existing. Immense, unbothered, silent. Black holes have that effect on us. They don't rise in our sky or shape our seasons, and yet they stir something primal, the way deep water does, or the dark woods at night. We know they're out there, swallowing stars and bending time, and yet our minds keep asking, how? Why? What's inside? What happens next? Sometimes, when you hear the phrase black hole, it's not about astronomy at all, it's emotional. I'm stuck in a black hole, someone might say. Everything just disappears. It's the metaphor we reach for when something feels endless, inescapable, or crushing. A breakup, a loss, a bout of insomnia that stretches on like it might never end. And that's telling. Because black holes aren't just scientific puzzles, they've become emotional shorthand for our deepest human fears. Oblivion, isolation, the fear that we too could vanish and leave no trace. But they also carry a strange comfort, a dark beauty. Like the ocean at midnight, they remind us there are things far older, deeper, and more powerful than we are. And for some, that's not terrifying, it's calming, humbling, even soothing. Have you ever looked up at the night sky, really looked, and felt your thoughts slow down, as if your worries, your to-do list, even your name started to feel small? Not insignificant, but simple, manageable, like whatever you were carrying could finally be set down for a moment, under the weight of 1,000 quiet stars. That feeling, that hush, is part of what black holes do to us. They're reminders of scale, not just physical, but temporal, because a black hole doesn't rush, it waits, patiently, silently. It could take millions of years to pull something in, to erase a star's memory, and yet once it does, there's no coming back. No light, no map, no echo. And here's the twist. We don't actually see black holes. Not directly. They have no surface, no colour, no outline. What we see when we look at them is their absence. The way they warp the light around them, the way stars dance nervously near their edges like moths circling a silent flame. Imagine that, something so powerful it defines itself by what it removes. It's a strange mirror for how we experience certain moments in our own lives. There are events, heartbreaks, disappearances, decisions, that we don't remember by what they were, but by what they took. The empty chair at the table, the silence after the call, the weight of what isn't there anymore. And yet, we keep circling the idea, just like stars. Even in fiction, black holes pull us in. They're everywhere, in stories, in dreams, in films that twist space and time into loops and paradoxes. Not just because they're dramatic, but because they represent a question we can't stop asking. What happens if I go beyond the known? That's the gravity at work. Not just in space, but in the mind. And when we think about them, late at night, eyes open in the dark, we're not really thinking about astrophysics. We're thinking about thresholds, limits, the edge of understanding, the end of the road, and what, if anything, might lie beyond it. Have you ever had a dream where you were falling? Not a nightmare, not a panic, just a slow, endless drift downward with no impact, no bottom, only motion. Black holes feel like that. At least the idea of them does. Not something hunting us, but something pulling softly, patiently, asking, do you want to know what happens next? It's no surprise then that the term event horizon feels so mysterious. It sounds like poetry, but it's science. The event horizon is the boundary of a black hole, the point of no return. Cross it, and not even light can escape. And doesn't that feel familiar? We've all had our own versions of event horizons, moments we crossed without realizing it, until we looked back and found the past unreachable. A final goodbye, a choice we can't undo, a moment that, in its quiet way, changed everything. The gravity didn't feel strong until it was too late to turn around. This is how black holes live in our minds, not just as collapsed stars, but as metaphors for emotional tipping points, for the limits of memory, for the places in our lives that resist explanation. But it's not all loss and silence. Some thinkers believe black holes might not be the end, but a door, a portal, a rebirth. And that's just as human a hope, the idea that nothing is ever truly gone, only transformed. That even at the centre of darkness there might be something new. And what about time? That old trickster slips in here too, because near a black hole time doesn't behave. It bends, slows, distorts. From far away it looks like you're moving in slow motion. To someone falling in it feels like everything else is speeding up. It's a strange paradox, time stretching and shrinking at the same moment, depending on your point of view. Which, again, feels oddly familiar. Have you ever had a moment so intense, so emotional or surreal, that time seemed to stop, or speed up, or collapse into a blur you can't quite put in order? Your first kiss, a loss, a narrow escape, a dream. That's what black holes teach us in a way, not just about physics but about perspective, that time and space and even reality itself might be less fixed than we think, that how we feel and where we stand shapes what we understand. And isn't that a little comforting too? To know that even in the cold, indifferent stretches of the cosmos, reality still makes room for subjectivity. That a black hole, no matter how alien, still reminds us of us. Our fears, our wonder, our longing to know what lies just beyond the next horizon. So maybe that's why they haunt us. Not because they're terrifying, but because they reflect the deepest parts of being human. Our curiosity, our grief, our awe, our stubborn refusal to stop asking questions even when the answers are cloaked in shadow. We can't see them, but we feel their pull, not just out there, in here too. Long before telescopes scanned the sky and equations danced across chalkboards, there were stories. Humans have always looked up, always wondered, always told each other tales to make sense of the stars. We didn't call them black holes, of course. We didn't know their names or their nature. but we sense them in dreams, in dread, in the dark places of the cosmos where light seemed to vanish and never return. Because even before we knew what we were looking at, we understood something about the void. We knew that the sky, for all its beauty, was hiding things, and so we named those shadows with our myths. The ancient Egyptians believed that each night the sun god Ra sailed through the underworld, a vast and dangerous realm called Duat. There, he would confront the serpent Apep, a monstrous force of chaos that tried to devour the sun and plunge creation into eternal darkness. Some scholars think of Apep as a kind of mythic black hole, a devourer, a darkness so vast it threatened reality itself. But Ra always emerged victorious, and so the sun rose again. In Hindu cosmology, the universe is constantly created, destroyed, and reborn in cycles. The god Shiva dances at the end of time, dissolving the cosmos so it can be remade. Some of these stories speak of cosmic voids, moments between creation and destruction, where everything collapses into nothingness. It echoes eerily with modern ideas of gravitational collapse, of matter imploding into singularity, waiting for the next breath of time. The Norse told of Ginnungagap, the yawning void, a primal nothingness that existed before the worlds were formed and perhaps after they fall. When Ragnarok comes, when the gods fall and fire consumes the branches of Yggdrasil, all things will dissolve into that gap once more, a kind of cosmic reset, an erasure not unlike the hypothetical fate black holes may bring, the information paradox, the slow fade into heat death or worse, deletion. In many indigenous traditions, the sky is not just a space but a living memory. The Navajo see the Milky Way as a pathway, a shimmering bridge of spirit and story. In some Andean cosmologies, dark patches in the night sky, where no stars seem to shine, are not empty at all. They are constellations of shadow, animals and beings woven from absence, not light. What Western astronomy calls dark clouds in the Milky Way, these cultures see as cosmic forms full of meaning. The llama, the fox, the serpent, black shapes in the sky, more vivid than the stars themselves. And isn't that exactly what a black hole is? A shape made of shadow, a presence carved out of disappearance. For centuries cultures spoke of underworlds, realms beneath or beyond, where souls travelled, where light failed, where time lost its way. Greek mythology gave us Tartarus, a deep abyss used to imprison the most ancient forces. It lay beneath Hades, darker, deeper, more eternal. In one version of the myth, it was so far below the surface that if you dropped an anvil, it would take 9 days to reach the bottom. That image of a fall with no end sounds strangely like what happens at the event horizon. Once you cross, there's no return. The fall becomes eternal. Time itself begins to stretch, warp, whisper. And yet, for most of human history, we had no name for this. We saw only hints. In the 18th century, as telescopes improved and Newton's laws began to reshape how we saw the universe, some thinkers began to toy with a strange idea. What if there were stars so massive their gravity could trap even light? A British philosopher named John Michell wrote a letter in 1783 proposing just that, a dark star whose escape velocity exceeded the speed of light. He had no way to prove it, no math to follow it. But the idea was there, a whisper before the shout. Still, the term black hole wouldn't arrive until the 20th century, and even then, only after we'd entered a new era of cosmic imagination. In 1915, Albert Einstein published his theory of general relativity, showing that gravity isn't just a force, it's a warping of space and time itself. Suddenly the universe became bendable, soft, dynamic, and lurking in Einstein's equations was something strange, a possibility, a kind of singularity. It was Karl Schwarzschild, a German physicist and soldier serving on the Russian front during World War I, who first solved Einstein's field equations and found a solution describing a collapsed object, something with a boundary, now known as the event horizon, beyond which no information could escape. He died of illness soon after, but his math lived on, waiting for the rest of the world to catch up. Still, even Einstein himself doubted that such things could really exist. They seemed like mathematical curiosities, too extreme, too absolute. Nature, he thought, surely had better taste, but nature, as it often does, had other plans. By the mid-20th century, scientists like J. Robert Oppenheimer and John Wheeler began to seriously consider what would happen when a massive star ran out of fuel. With nothing left to support its weight, it would collapse under its own gravity, shrinking, compressing, falling inward until even light was trapped. Wheeler is the one who gave this idea its name, the black hole. He meant it quite literally. Not a metaphor, not a shadow, but a region of space with no escape, no surface, no return. But language has a funny way of carrying echoes, because even now, decades later, black hole still feels like more than physics. It feels like myth, like metaphor, like something ancient that found new clothes in the light of science. And around the world, cultures began to absorb the idea. In popular media, black holes became symbols of danger. The villainous portals in space operas, the swirling maws in animated films, the thing that eats the ship if you veer too far off course. But they also became something more subtle, a symbol for the unknowable, the ineffable, the edge of science and spirituality where understanding dissolves into silence. In modern literature and film, the black hole is often portrayed not just as a physical threat, but as a philosophical one. In Interstellar, a black hole named Gargantua bends time so dramatically that minutes near its surface become years far away. In Contact, it's the place where memory, science, and faith blur together. In Dreams, it becomes the symbol for emotions we cannot name: longing, grief, wonder. And through it all, we continue to ask the same questions, just in different languages. In Japanese, the term for black hole is brakuhoru, a transliteration. But in poetry and art, it often becomes a void where memory lives. In Arabic, thukb aswad, carries an air of mystery, like a tear in the fabric of the world. In Spanish, agujero negro, like a hole in the soul of the cosmos. Some languages speak of them not as holes, but as eyes, the eye of the void, the pupil of the night, a place that looks back. And perhaps, in a way, it does. Because the more we study black holes, the more they reflect us, our curiosity, our limits, our fear of forgetting, our hunger to understand. They're the final stop on the line between science and story, where Newton hands the baton to Nietzsche and telescopes meet dreams. Even now, in classrooms and observatories, scientists wrestle with their mysteries. We measure their spin, map their shadows, debate their paradoxes, but we still describe them in human terms. We say they have appetites. We talk about them eating stars. We imagine them as traps, or monsters, or gateways. Because that's what we do. We tell stories around the campfire, even when the fire is a dying star, and the stories don't all agree. Some say black holes are the end, the universe's final eraser. Others say they might be the seeds of new beginnings. Some theories suggest that every black hole could birth a new universe inside, like a Russian doll of realities. Others propose that information isn't destroyed at all, just scrambled beyond recognition, waiting, somehow, to be recovered. In Hindu thought, destruction is not a bad thing, it is part of a cycle. In Buddhist cosmology, there are vast kalpas, cosmic timescales so long they make black hole lifespans seem short. The death of a star is not the death of all things, it is transition, transformation. Even in the Torah and the Bible you find whispers, phrases like the deep, the void, the darkness upon the face of the waters. Language meant to grapple with things that cannot be seen, only felt. And in our modern myths, the language of comics, cinema, and speculative fiction, black holes become metaphors for rebirth, resurrection, time travel, infinite memory. They are wombs as well as tombs, labyrinths as well as prisons. We still don't know what lies inside them. Not really. We know the math, we know the theories, but no human, no probe, no particle, no photon has ever returned from inside an event horizon. It is the ultimate silence, and yet, across history and culture, that silence has always spoken to us. In drums, in dreams, in symbols carved into stone, and tonight it speaks still, in the hush between your breaths, in the dark just beyond your window, in the space between stars where something vast and unseen is waiting, not to harm, not to hunt, just to be. And so we keep watching, keep wondering, keep telling stories, in data, in myth, in whispers, because even if we never fully understand them, black holes remind us of something essential, that the universe, in all its brilliance, still contains shadows, and that even in those shadows there is meaning. Let's drift now from myth into method, from metaphor into mathematics. Though don't worry, we're not in a hurry. We'll unfold it gently, like a blanket warmed by thought. To understand black holes, we begin not with darkness, but with gravity. Gravity isn't just what holds your cup to the table, or keeps your feet on the floor. It's the quiet sculptor of the universe. It gathers gas into stars, stars into galaxies, galaxies into the vast threads and filaments of the cosmic web. Without it, there'd be no structure at all, just particles drifting forever, never touching. But gravity isn't only a force, at least not anymore. In 1915, Albert Einstein changed everything. He proposed that gravity isn't something that pulls, but something that bends. According to his general theory of relativity, mass tells space how to curve, and space tells objects how to move. Picture a stretched sheet of fabric. Place a bowling ball on it, and the sheet dips. That's what mass does to space. Now roll a marble nearby. It curves inward, not because it was pulled, but because it followed the shape of the sheet. Gravity, in Einstein's view, is geometry. And black holes are the most extreme geometry we've ever imagined. When a massive star runs out of nuclear fuel, that steady fire in its heart that pushes outward, gravity takes over. With no more pressure to fight back, the star collapses inward. Its core squeezes tighter and tighter until, in some cases, it passes a point of no return. The matter becomes so dense, so compact, that it warps space-time into a pit no light can climb out of. That's a black hole. Not a thing, really. Not an object. But a region of space, curved so intensely that it disconnects from the rest of the universe. At the heart of this invisible region is something called a singularity, a place, or perhaps a state, where density becomes infinite, where our equations break down. It's not just that we don't know what happens there. It's that our current physics can't know. The math divides by zero. Time and space twist into a knot too tight to untangle. Surrounding this singularity is the event horizon, the border, the edge. From outside you can orbit a black hole, shine a light at it, throw pebbles into it. But once anything crosses that invisible threshold, light, matter, even information, it cannot escape. It's gone, at least as far as we can tell. For decades, we weren't even sure black holes really existed. They made sense in the math, but were they just theoretical artifacts, or actual entities lurking in the night sky? The answer came from the stars themselves. Astronomers began to notice strange things. Pairs of stars where one was invisible, but its companion star was orbiting something hard, fast. Sometimes, matter from the visible star would spiral toward its unseen partner, heating up as it fell, glowing in X-rays. Too small to be a cluster, too heavy to be empty space. The invisible object had to be incredibly massive and incredibly compact. A black hole. One of the first strong candidates was discovered in the 1960s, Cygnus X1, a mysterious X-ray source in the constellation Cygnus, eventually confirmed as a stellar mass black hole, formed most likely from the collapse of a massive star. But Cygnus was just the beginning. Over time we found more, some just a few times the mass of our Sun, others hundreds, even thousands. And then came the real giants, not lurking in distant star systems, but resting at the centres of galaxies. Supermassive black holes, millions, even billions of times the mass of the Sun. Quiet, patient monsters around which entire galaxies whirl. The one at the heart of our own Milky Way is called Sagittarius A, a compact object over 4 million times heavier than our star, and it's not just sitting there, it's spinning, feeding, burping jets of radiation into space, slowly, invisibly shaping the galaxy we call home. But if we can't see black holes, how do we know they're there? We know because of what they do to the world around them. When matter falls toward a black hole, it doesn't just vanish quietly. It heats up, forming a swirling disk, called an accretion disk, where particles crash into one another at near-light speeds. These disks can glow brighter than entire galaxies. Some shoot out jets, beams of plasma that stretch across light years. In 2019, a global collaboration of scientists, using a network of radio telescopes called the Event Horizon Telescope, captured the first image of a black hole's shadow. Not the black hole itself, remember, that's invisible, but the glowing halo of hot gas spiralling around it, bent by gravity into a ring of fire. It was breathtaking, a bright orange circle, blurry at the edges, with darkness in the centre, the absence of light. A literal silhouette of the void. That shadow revealed the black hole at the heart of the galaxy M87, 55 million light-years away. A supermassive giant 6.5 billion times the mass of the Sun. And for the first time, we saw the invisible. Not through metaphor, but through measurement. It was one of the most poetic moments in scientific history. An ancient myth finally meeting its modern mirror. But black holes aren't just cosmic curiosities. They warp the rules. Time, for instance, behaves very strangely near them. According to relativity, the stronger the gravity, the slower time moves. Near a black hole, time slows dramatically. A clock orbiting close to the event horizon ticks slower than one far away. From your point of view, you're moving normally. But to an observer farther out, you appear to be moving in slow motion. If you fell into a black hole, and let's hope you don't, the experience would be strange indeed. From your perspective, you'd fall freely, quickly, crossing the event horizon in a moment. But to someone watching from a distance, you'd seem to slow down, hover, freeze just outside the horizon, forever redshifting into darkness. It's as if time itself breaks in two. Fast for you, slow for the rest of the universe, and then nothing. From the outside, you vanish. From the inside, no one knows. Do you hit the singularity? Are you stretched into spaghetti by tidal forces? What physicists affectionately call spaghettification? Or do you go somewhere else? Some theories suggest the singularity is a kind of bridge, a passage to another region of space, or another universe entirely. A wormhole, a tunnel, a doorway. Others say no. It's an ending, a final punctuation mark where matter, time, and knowledge all collapse. And here's where the science gets stranger still. Because for a long time, physicists believe that anything that falls into a black hole is lost forever. Not just physically, but informationally. That means the data describing its structure, its properties, even its history, gone. But that idea clashes with a fundamental rule of quantum physics. Information cannot be destroyed. Even when you burn a book, the information isn't gone. It's scrambled in the ash, the smoke, the photons. In principle, it's recoverable. But black holes delete. Or do they? This is the black hole information paradox, one of the most important puzzles in modern physics. And like all great questions, it's still unresolved. Some scientists believe that the information is encoded on the event horizon itself, like a cosmic hard drive. Others think that as black holes evaporate, a process predicted by Stephen Hawking, where black holes slowly emit radiation over time, the information leaks out subtly, mysteriously, and some say we're still missing a piece. A new physics waiting in the wings, a theory of quantum gravity that will unite the geometry of spacetime with the probabilistic haze of quantum mechanics. Because as it stands, general relativity and quantum theory, our two best models of reality, don't play nicely near black holes. One curves the universe, the other quantizes it, and at the singularity both collapse. But perhaps that's exactly why black holes matter so much. Not just because they're dramatic or dangerous or mysterious, but because they sit at the crossroads of our knowledge. They're where our current understanding ends, and where the next great leap must begin. They ask questions we can't yet answer, and maybe never will. But we keep trying, because that's what science does, what humans do. We reach for the light, and sometimes we peer into the dark. Black holes are often thought of as endings, but perhaps they're more like punctuation marks, commas, not periods, pauses in the story, heavy with meaning, but not the final word, because while they may seem like cosmic erasers, there's something deeper, stranger, and altogether more unnerving going on beneath their event horizons, or maybe even on them. In the 1970s, a young physicist named Jacob Bekenstein had a wild idea. He proposed that black holes should have entropy, a measure of disorder or information. This was radical. Until then, black holes were thought to be simple, completely described by just three things: their mass, their charge, and their spin. Hairless, the physicist said. Black holes have no hair, meaning they don't keep the messy details of the matter they swallow, just the bare essentials. But Bekenstein argued that if a black hole hides information, then it must have entropy. And if it has entropy, it should also have temperature. And if it has temperature, it should radiate. That last part shocked almost everyone, because black holes by definition let nothing escape, not even light. But just a few years later, Stephen Hawking, working with quantum field theory and curved spacetime, showed that Bekenstein was right. Black holes do radiate, slowly, subtly, through a process now known as Hawking radiation. Here's how it works, at least in theory. In the quantum vacuum near the event horizon, particles and antiparticles constantly pop into existence, then annihilate one another, but occasionally one particle falls into the black hole while the other escapes. To an outside observer, it looks like the black hole is emitting particles, losing mass. Over time, vast, unimaginable stretches of time, the black hole evaporates, shrinks, disappears. And that's where the question deepens. If a black hole vanishes, what happens to the information it swallowed? Does it leak out with the radiation? Is it encoded in subtle correlations between the particles? Or is it simply lost, deleted from the universe, leaving behind no record, no trace, no possibility of reconstruction? If the latter is true, it would mean something profound and troubling. It would mean the universe has holes in its memory. That information, once gone, cannot be recovered. That the past is not merely hidden, it is erased. And yet quantum mechanics resists that idea. In the quantum world, everything is reversible. Every process has a mirror image. If you know the present precisely, you can, in principle, work backward and reconstruct the past. The universe doesn't forget, but black holes might. This is the heart of the black hole information paradox. Not just a physics puzzle, but a philosophical one. A riddle about memory, time, and the permanence of being. Some physicists believe the solution lies in holography, the idea that all the information inside a black hole is actually stored on its surface, not inside the volume, but on the boundary. Like a cosmic library etched into the fabric of the event horizon. This led to the holographic principle, a theory that suggests the entire universe might be described, not by the 3 dimensions we live in, but by information encoded on a 2-dimensional boundary far beyond what we can perceive. It sounds wild. It is wild. But mathematically, it holds together. In some models, a universe full of volume and depth might emerge from a flat page of quantum information. In this view, black holes don't delete the universe. They compress it. They fold reality in on itself like data in a zip file. Dense, cryptic, but still there. And yet, no one's quite sure if that metaphor holds beyond the math. After all, you can unzip a file. You can't exactly unzip a singularity. Other ideas have emerged. Maybe the information escapes slowly through subtle fluctuations in Hawking radiation. Maybe it's released in a final flash, when the black hole shrinks to a quantum dot and bounces back, like a cosmic cough, returning its secrets in one burst of revelation. Or maybe the information doesn't leave at all. Maybe it leaks into other dimensions, slipping sideways into realities we can't yet measure. A kind of cosmic laundering, gone from here but not from everywhere. And then, of course, there's the darker possibility. Maybe black holes do delete, not carelessly, not cruelly, just naturally, like a tree shedding leaves in winter, like a mind forgetting a dream. Maybe the universe forgets on purpose. Maybe it has to. After all, if information were never lost, if every particle, every collision, every whisper of motion persisted forever, the cosmos would grow unbearable, cluttered, overfull. Perhaps deletion is mercy. Perhaps black holes are not just destroyers, but editors. Still, the question lingers. Can black holes delete the universe? And the honest answer is, maybe. Not suddenly, not dramatically, but slowly, quietly, over trillions of years. Black holes are patient. After the last star has died, after the last galaxy has gone dark, black holes will remain, slowly evaporating into silence. If the theory of heat death is correct, then the universe's end will not be a bang, but a fade. A long, slow drift toward maximum entropy, where all energy is evenly spread, all structure erased, all distinction dissolved. Black holes may be the last active players in that story, the final places where things happen. They will swallow the last light, evaporate the last heat, and then nothing. A silent universe, a dark plane, a vast cold simplicity, or perhaps not. Perhaps at the end, in some way we can't yet imagine, black holes will give something back, a seed, a spark, a glitch in the nothing, the beginning of something new. Some cosmologists believe that black holes may be linked to the birth of new universes, that inside every event horizon, a new cosmos unfolds, disconnected from our own, expanding on its own clock with its own laws of physics. If that's true, then a black hole is not the end of a story. It's the beginning of one we'll never read. A doorway, not a deletion. An echo, not an absence. And what does it mean then to delete the universe? Maybe the question itself is incomplete. Maybe deletion and creation are part of the same act. Two sides of a cosmic coin, flipping endlessly in the dark. After all, even when a star dies, it gives birth to something new, a nebula, a black hole, a whisper of gravity that might one day gather dust into new stars. Maybe black holes are gardeners, pruning the cosmos, clearing space for the next bloom. And maybe, just maybe, the reason we can't stop thinking about them isn't fear, it's hope. Hope that even in the darkest places the story goes on. Hope that the universe, like us, forgets just enough to move forward, remembers just enough to matter, and deletes, not to end things, but to begin again. So when we ask if black holes can delete the universe, we're really asking something deeper. Can endings be beginnings? Can silence be a kind of song? Can what is lost still mean something? The answers, for now, live beyond the horizon. But we keep listening, and that, like the universe itself, is a beautiful, endless thing. Let's sink deeper now. Not in fear, but in fascination. We've circled black holes from a distance, gazed at the shadows they cast and marvelled at the silence they keep. But if you're ready, let's drift in a little closer, gently, curiously, into the mechanism itself, into the edge of the abyss. Black holes may seem like sudden things, cataclysmic, devouring, destructive. But in truth, they begin quietly, with gravity doing what gravity always does, pulling inward. When a massive star exhausts its nuclear fuel, its inner furnace dies, and with that death, balance is lost. The pressure that once held gravity at bay fades like the last warmth of a fire. The star begins to collapse. In the smallest stars, that collapse might end with a white dwarf. Dense, yes, but stable. In larger stars, a neutron star might form, the size of a city, but heavier than our sun. But beyond a certain point, even the force that holds neutrons together, the strong nuclear force, can't resist the pull. And then, collapse becomes complete. There is no more thing resisting gravity. The matter keeps shrinking, space keeps curving, and what remains is not an object, but a region. A black hole. A hole in space-time itself. But what's inside? At the centre lies the singularity. Not a dot you can draw, but a region where our understanding breaks. A place of infinite curvature, infinite density, and depending on who you ask, maybe infinite mystery. It's a one-way path in space-time. Not a place, but a destination with no return address. Surrounding this is the event horizon, the boundary, the edge, the point where escape becomes impossible. If light cannot leave, then neither can information, matter, energy, or regret. Now here's something strange. The event horizon has no physical surface. You wouldn't feel it if you crossed it. No bump, no flash, no sound. It's not a wall. It's a tipping point, a threshold you only recognize once it's behind you. And past that, physics becomes dreamlike. The closer you get to the singularity, the more intense the curvature becomes. Objects stretch vertically and compress horizontally, a phenomenon known affectionately as spaghettification. You'd be pulled into long, thin strands of matter. It sounds like cartoon logic, but it's deadly real. Tidal forces so extreme that even atoms get torn apart. For stellar mass black holes, say 10 or 20 times the mass of our sun, this happens violently long before you reach the centre. But with supermassive black holes, like the one at the heart of the Milky Way, the tidal forces near the event horizon are far gentler. It's entirely possible you could cross the boundary and not notice, until it was far too late. Which brings us to a haunting question. If you fall into a black hole, where do you go? One answer is nowhere. You cease to be. You become part of the singularity. Another answer, a wilder one, is that you pass through. And that's where wormholes enter the story. Wormholes, or Einstein-Rosen bridges, are theoretical tunnels through space-time, shortcuts between two distant points, or perhaps even two different universes. The math that describes black holes also permits the existence of these wormholes, but they come with problems. They require exotic matter, matter with negative energy density, to stay open. In other words, something we've never observed, can't currently produce, and may not even exist. Without it, a wormhole would collapse before you could blink. But the idea is too beautiful to abandon. Imagine falling into a black hole and emerging somewhere else, not crushed but translated, rewritten into another part of space-time, a cosmic subway, a dark hallway that leads not to an end but to a new beginning. It's speculative, highly, but even speculation, when done gently, can be a kind of lullaby. Now let's imagine a different extreme. Not a hole that pulls things in, but one that throws things out. Physicists call this a white hole. In theory, a white hole is the time reverse of a black hole. Instead of letting nothing escape, it allows nothing to enter. It only emits matter, never swallows it. A cosmic fountain forever expelling but never absorbing. Have we ever seen one? No, not even a hint. But the equations allow it. And if time is symmetric, if you can run the film forward and backward and still get valid math, then white holes should be possible. Some theories go even further. They suggest that what we call a black hole from one side might look like a white hole from another. That the inside of a black hole could birth a new region of space-time, where everything it consumed is re-expelled in a new beginning. In other words, black holes might not be graves, but wombs. This leads to an even wilder possibility, one that sounds like science fiction, but lives quietly in theoretical physics journals. Black holes may be seeds for new universes. Think of it like this. Our own universe began, as far as we can tell, in a singularity, a point of infinite density. What if that singularity was inside a black hole? Not ours, but someone else's. What if every black hole everywhere contains its own Big Bang? A universe within a universe? Fractal cosmology. An endless nesting doll of realities, each one blooming from the collapse of another. We don't know. We may never know. But the thought is gentle, isn't it? That what looks like an end might be a beginning in some hidden way. Now let's drift back towards certainty, or at least the closest thing we have. Black holes are defined by three basic properties: mass, spin, and charge. Their mass determines their size. The larger the mass, the wider the event horizon. Their spin, or angular momentum, tells us how quickly they're rotating. Most black holes spin, some very fast, near the speed of light. This spin twists space-time around the hole, dragging it into a whirlpool-like structure known as the ergosphere. In the ergosphere, strange things happen. Particles can enter and split. One part falls in, and the other escapes with more energy than it had going in. This process, the Penrose process, may be how some black holes lose energy over time, aside from Hawking radiation. And charge. In practice, most black holes are thought to be nearly neutral. Any charge they gain is quickly balanced by surrounding particles. But in theory, a charged black hole, called a Reissner-Nordström black hole, behaves differently, with layered horizons and strange internal structure. We're entering a realm where black holes are not just vacuum cleaners but machines, engines of physics, portals, paradoxes, prisms through which we glimpse new laws. And then there's rotation. A rotating black hole, a Kerr black hole, isn't static. It has an axis, a direction, a dance. Its spin warps space-time into a funnel that loops, twists, and spirals. Near its core, paths bend violently. There may even be closed time-like curves, paths through space-time that lead back to where they began. In other words, time loops. Yes, the math allows for it. You could, in theory, follow a trajectory that brings you back to your own past. Whether this can happen physically, or whether nature somehow forbids it, we don't yet know. But it's enough to make your breath slow, to make your thoughts drift, that near the edge of a collapsed star, time might curl into a spiral and shake hands with itself. All this from a dead star. All this from gravity's quiet hunger. And yet, for all their complexity, black holes remain remarkably simple on paper. A handful of parameters, a few letters in an equation. But inside those letters is a storm, a universe folded inward, a silence loud with meaning. It reminds us that simplicity and mystery are not opposites. Sometimes the deepest mysteries wear the quietest clothes. Even in their simplicity, black holes conceal more riddles than we can yet count. And the deeper you fall into the math, the more the rules of the universe begin to flicker, not break exactly, but bend in ways that make you wonder if everything we've known so far has only been a prelude. One of the most important of these riddles is called black hole entropy, and it's not just about chaos, but about knowledge, or rather, the loss of it. Entropy, in its simplest form, is a measure of disorder. A shuffled deck has more entropy than a sorted one. A room in disarray has more entropy than one carefully organised. But entropy also measures how many ways a system can be arranged without changing what we see on the outside. Now imagine a black hole. On the outside you see just three things: its mass, its spin, and its charge. But it may have swallowed stars, books, memories, civilizations. All of that gone from view, erased from the visible world. According to Bekenstein and Hawking, the entropy of a black hole is proportional to the surface area of its event horizon, not its volume. That's strange. Most objects have entropy that scales with how much stuff is inside, but black holes, it's all on the surface, as if all the complexity inside is somehow smeared on the border, like a hologram, like a whisper of what was lost. And here's what makes it more curious. The entropy of a black hole is enormous, far, far greater than any ordinary object of the same size. That suggests black holes are the most entropic, the most information-rich things in the universe. Which is ironic, isn't it? The thing that swallows everything also holds the most. The ultimate destroyer is also the ultimate librarian. But the library is locked. The pages are scrambled. The books are written in a language we haven't learned to read. Still, entropy gives us a clue. It tells us that something is preserved. Not the forms, not the stories, but the count of possible arrangements. And in physics, that's not nothing. That's structure. That's a thread. So we follow it. But as always, threads lead to tangles. Take the idea of cosmic censorship, a proposal by physicist Roger Penrose, suggesting that nature hides all singularities behind event horizons. In other words, we can't see the true core of a black hole, because spacetime covers its nakedness. It's a comforting idea in a way, that the universe is polite, that it keeps its secrets behind curtains. But what if it doesn't? What if a singularity can be exposed? A naked singularity unshielded by an event horizon would be visible, and that would break determinism, the idea that the future follows logically from the past. Physics would lose its power to predict. Some simulations suggest naked singularities could exist, under rare and extreme conditions. Others argue that such situations would always collapse back into censorship, but either way, the possibility rattles the foundations of causality, our belief in cause and effect, before and after. It suggests that the universe at its edges might not be ruled by logic at all. Now add another puzzle to the stack, the firewall paradox. It began as a question. What happens to an astronaut who falls into a black hole? According to general relativity, they shouldn't feel anything at the event horizon. No bump, no heat, just quiet, curved space-time. But quantum mechanics complicates that. In 2012, physicists proposed that to preserve unitarity, the idea that quantum information is never lost, something drastic must happen at the horizon. A firewall. A wall of high-energy particles that burns anything crossing it. A violent break in the smooth geometry Einstein promised. If true, this means the event horizon isn't soft and silent, but scorching, deadly. A cosmic electric fence that no one can pass. This contradicts relativity. It breaks the idea that space is continuous and gentle at the boundary. So which is right? We don't know. The two theories, quantum mechanics and general relativity, are both precise, both tested, both beautiful. But here, at the edge of the black hole, they disagree, and the universe doesn't break ties for us. This is where the search for a quantum theory of gravity becomes not just an academic exercise, but a necessity. We need a framework that unites the geometry of space with the uncertainty of particles. A theory that can tell us, gently, clearly, what happens at the horizon. Until then, we drift. We imagine. We write papers, run simulations, dream up holograms, and foam-like structures of space-time. Some physicists propose that space-time itself is made of quantum bits, tiny units of information, woven together like a fabric. If true, then black holes are knots in that fabric, places where the weave becomes dense, compressed, hidden. Others suggest that black holes are not singularities at all, but fuzzballs, tangled webs of strings and brains, as described in string theory. In this view, the black hole has no interior. Everything is on the surface, humming with vibration, a holographic fuzz. It sounds strange. But the closer we get to black holes, in our thoughts, our equations, our instruments, the more we realize that strange is the norm near the edge of knowledge. The rules we trust begin to flicker. Time, space, matter, memory, all of them bend. And yet, even as the math tangles and the paradoxes pile up, black holes never stop inviting us in. Not as monsters, not as villains, but as teachers. Because the more we learn about them, the more we learn about everything else. About information, about energy, about the birth and death of time itself. They show us how to look at the ordinary with new eyes. That entropy is not just disorder, but possibility. That information, once thought lost, may simply be waiting in a new form. That endings are invitations, that boundaries are only beginnings in disguise, and maybe, just maybe, that darkness is not the opposite of knowledge, but its cradle. Because even now, in our modern data-soaked age, we don't know what happens inside a black hole. We can describe it, approximate it, simulate it. But the real thing, the truth of it, is still out of reach. Like a dream you almost remember. Like a melody you once heard in a half-sleep state, now fading. That's the mystery we drift toward. Not in panic, not to solve it all, but to feel the quiet beauty of not knowing, and black holes remind us that the unknown isn't empty. It's full of meaning, full of wonder, full of possible answers still waiting behind the veil. We often think of black holes as discoveries of the modern age, born in labs and math journals, dressed in data and diagrams, but their story begins not in a telescope, but in a question. One asked long before we had the words to answer it. It begins, as many cosmic tales do, with Newton. In the late 1600s, Isaac Newton gave the world a new kind of language, one where the universe behaved like a grand machine. Planets obeyed forces, apples fell with reason, and the same gravity that held you to the ground also guided the moon around the Earth. He imagined gravity as an invisible tether, stretched between objects, and with that, the stage of physics was set. But Newton's framework had no concept of light being affected by gravity. It was assumed to travel instantly, or at least too fast to be bothered. Still, the seeds of deeper questions were already falling into the minds of the curious. In 1783, a British thinker named John Michell asked something extraordinary. He wondered, if gravity could slow objects down, could there be a star so massive that not even light could escape its pull? He imagined a dark star, invisible because it captured its own glow. He even estimated how big such a star would need to be. Using Newtonian mechanics, he argued that if a star were compressed into a certain radius, its escape velocity would exceed the speed of light. At the time, it was little more than a curiosity, a mental game. No one believed such things could truly exist. After all, what could possibly stop light? Light was the messenger of the heavens, the divine spark, the symbol of all that could be seen. Still, Michel's idea lingered. A few years later, the great French mathematician Pierre-Simon Laplace arrived at the same conclusion, though he quietly removed it from later editions of his work. Perhaps it felt too speculative, too strange. Ideas, like stars, sometimes go unnoticed until the time is right. Fast forward a century. In 1915, Albert Einstein published his general theory of relativity, a framework not just for gravity, but for the very shape of space-time itself. According to Einstein, mass tells space-time how to curve, and curved space-time tells matter how to move. Gravity wasn't a force anymore, it was geometry. The universe became flexible, a dance of fabric bent by stars and planets, and in the equations that describe this bending, something unexpected appeared. That same year, a German physicist named Karl Schwarzschild was serving on the front lines of World War I. In the muddy, harrowing stillness between battles, he found time to solve Einstein's equations for the simplest case, a single spherical mass, like a star. To his surprise, the solution contained a boundary, a radius at which the equations behaved strangely. This radius, now called the Schwarzschild radius, would later become the defining size of a black hole's event horizon. Cross that line, and escape becomes impossible. Schwarzschild didn't call it a black hole, in fact neither did Einstein. Even as late as the 1930s, Einstein rejected the idea that such collapsed objects could exist. He believed nature would find a way to avoid such extremes, but the math was persistent. In 1939, J. Robert Oppenheimer, yes, the same man who would later lead the Manhattan Project, co-authored a paper exploring the collapse of massive stars. He showed that, under certain conditions, nothing could stop the implosion. Once a star crossed the Schwarzschild radius, its fate was sealed. The collapse would continue. A singularity would form. Still, the term black hole didn't exist. Oppenheimer's work was largely ignored, filed under theoretical oddities. The war and the world had other things on its mind. Then came the space age. By the 1960s, astronomy was booming. Satellites scanned the skies in radio, X-ray and infrared. New kinds of stars were discovered. Pulsars, quasars, strange compact objects that didn't behave like anything we'd seen before. Astronomers noticed binary systems where one star was visible and the other invisible, yet exerting an immense gravitational pull. Matter spiraled into nothing, glowing fiercely in the fall. Something massive was there, but unseen. It was during this time that the American physicist John Archibald Wheeler finally gave these objects a name, black holes. He meant it as a description, a hole in space-time from which nothing escapes, not even light. But the name stuck, not just in science, but in the imagination. For the first time, black holes weren't just theoretical, they were observational, real. In 1964, Cygnus X1 was identified as the first strong black hole candidate, a source of X-rays in the constellation Cygnus, linked to a massive but invisible object. It didn't glow, but its partner star danced around it. And in that dance, the darkness revealed itself. Then, in the 1970s, Stephen Hawking entered the story, and nothing was ever the same again. Hawking applied quantum theory to the curved space-time of a black hole's edge. What he found was astonishing. Black holes should emit radiation. This Hawking radiation, as it's now known, changed everything. Black holes weren't eternal, they could slowly evaporate, fade, die. It was an idea as poetic as it was scientific, that even the darkest, most isolated regions of the universe are not completely silent. They whisper, they lose, they change. Hawking's work didn't stop there. He wrestled with the implications for decades, debating with colleagues about whether black holes truly destroy information. The so-called information paradox became one of the great unsolved questions of theoretical physics. Each new advance deepened the mystery. In the 1990s, string theory offered a possible explanation, suggesting that black hole entropy could be explained by the vibrations of fundamental strings. The holographic principle emerged, proposing that all the information within a volume of space could be encoded on its boundary. Black holes weren't just astrophysical objects anymore, they became laboratories for ideas, for theories of gravity, of information, of the very nature of reality itself. And still, observations rolled in. The Event Horizon Telescope, a global array of radio dishes, captured the first real image of a black hole's shadow in 2019, a glowing orange ring in the heart of galaxy M87. Not the black hole itself, of course, but the imprint it left in its feeding light, a silhouette of absence. That single image marked a turning point. The theoretical had become visible. The unseeable had left its mark on film. Meanwhile, gravitational wave detectors like LIGO, began capturing the ripples in spacetime from colliding black holes, brief murmurs in the cosmic sea, billions of light years away. With each chirp, a new kind of astronomy was born. The black hole was no longer a ghost in the equations. It was a performer on the cosmic stage. Quiet, yes, but present. And now, here we are. Barely a century since Schwarzschild's quiet calculations in the trenches, black holes have become central to our understanding of the universe, not just as endpoints, but as engines, as puzzles, as poems in geometry and mass. We still don't fully understand them. We don't know what the singularity truly is. We don't know how or if information is preserved. We don't know whether black holes connect to other regions of space-time, or whether they seed new universes from their cores. But perhaps that's the point, that even in our age of data and diagrams, some things remain beautifully uncertain, and black holes, for all their mass and menace, remind us that mystery is still part of the cosmos. They are the shadows we chase, the questions we carry, the places where science and story quietly hold hands. And the journey from dark star to quantum hologram isn't just about physics, it's about perspective, about how we, as a species, learn to look deeper. First with wonder, then with math, then with machines that stretch across continents, and finally, perhaps with humility, as we realize how much more there is to know. So next time you see a star or feel the pull of gravity in your own body, remember, we are part of that story too, made of the same matter, bound by the same forces, and somewhere not too far in cosmic terms a black hole is turning, spinning, waiting, not to end things, but to remind us how little we've yet to see. Black holes begin in physics, but they don't stay there. Their gravity doesn't just pull in stars and light, it pulls in language, metaphor, memory. They slip into our poetry, our dreams, our fears. They become shorthand for what we cannot describe, for the places our science and stories don't yet reach. Because black holes ask questions that aren't always about space, but about us. What happens when something disappears? Does it truly cease to exist, or does it just become hidden? There is a deep quiet around black holes, and not just in the vacuum of space. It's the quiet of unanswered. The quiet of the final page turned, but the story still lingering in your chest. We look at black holes and wonder, is this what death is? Not the end, but a crossing, a point of no return, a threshold through which something passes, not with fanfare, but with silence. The singularity, the heart of the black hole, feels like the ultimate unknowable. Not a place we haven't explored yet, but a place we can't. Not just because it's far away, but because it exists beyond the structure of our understanding, beyond time, beyond space, beyond words, and that beyondness haunts us and humbles us. Because so much of what we call truth is built on being able to look, to measure, to explain. But the singularity shrugs off all of that. It stands or collapses in perfect disregard for our tools, and maybe we're afraid that we're like that too, that at our core there might be something unmeasurable, something that can't be photographed or recorded, something not even language can name. Maybe that's what draws us to black holes. Not just the mystery of what they are, but the mirror they offer, a place that holds everything but shows nothing. A gravity that bends even time, yet cannot be seen. There is something deeply human in the desire to understand black holes. We look into the night sky and we want to find ourselves there. We see the void and we wonder if it can erase us, or if somehow it might remember. Because memory is what gives meaning to time. Without memory, the past dissolves. Without a future to imagine, time stops feeling like a journey and starts feeling like a room with no doors. Black holes sit at the intersection of these two ideas, memory and time. They take in matter, yes, but they also take in information, the fingerprints of everything that crosses the horizon, and yet we don't know if that information survives, if it's preserved, encoded, waiting, or if it's truly deleted, And isn't that the existential question? When we're gone, are we gone? Or are we somehow still rippling across the universe? The idea that information might be lost forever offends many physicists. It breaks the symmetry of things. It violates unitarity. The quantum law that says the total information in a system remains constant, even when it's scrambled beyond recognition. But emotionally, spiritually, even artistically, we struggle too. Because black holes challenge our ideas of permanence, of legacy, of knowing that what we've said, what we've made, what we've loved, can't just vanish. So when we imagine falling into a black hole, what are we really imagining? The death of the self, the survival of a shadow, a scattering of our story into particles, or a reassembly in another world? Physicist Lee Smolin once said that time might not be an illusion, that it might be the most real thing of all. Not space, not matter, but time. And black holes, by bending and stretching time, take that idea and run with it. Near a black hole, time slows. For an outside observer, you seem to freeze at the edge. For you, the fall continues. From your point of view, you cross the event horizon in finite time. For the rest of the universe, you hover at the brink forever, stretched into a ghost of light. Both experiences are real, both are true, but they don't agree. And perhaps that's the heart of existence. Multiple truths held in tension. Lived from within, measured from without. Are we more like the falling astronaut, living our own moment as it happens? Or more like the observer, watching our choices stretch towards some asymptotic future? Maybe black holes aren't just cosmic phenomena, but personal metaphors. Each of us carries our own singularities, our own hidden cores, shaped by experiences we can't explain, by pain we've tucked too deep to name. And like the event horizon, we have boundaries, edges past which we no longer show our full selves to others. We protect those centres, sometimes out of fear, sometimes out of love, but we still orbit them, still pulled by the gravity of the unspoken. Some thinkers believe black holes are the atoms of quantum gravity, fundamental, indivisible units that help us understand the architecture of the cosmos. And that brings us to another question, quiet but insistent. Are we too singularities in disguise? Bundles of memory, information, time, folded so densely into our bodies that we don't even see the mystery we carry. The poet Rainer Maria Rilke once wrote, "You must give birth to your images. They are the future waiting to be born." Black holes feel like that, not barren ends but pregnant moments, dense with possibility. And even now, some physicists believe black holes could be beginnings. That when a black hole forms, a new universe buds inside, disconnected from ours, invisible, untouchable. That our own Big Bang may have emerged from such a place, a black hole in another reality collapsing and breathing out our own. In that view, death and birth are the same act. Collapse is creation. Deletion is transformation. It's not an answer that science can confirm, at least not yet. But it is a kind of poetry, a way of imagining our place not as bystanders, but as participants in something vast, something ongoing. In Buddhist philosophy, the self is not fixed. Identity is fluid, ever-changing, dependent on causes and conditions. And in that light, a black hole is not so different. It changes with what it consumes. Its mass grows, its spin adjusts, its entropy rises. It is shaped by the story it absorbs, even if that story can no longer be told. And if black holes can evolve, perhaps they are not endings but processes, long, slow movements of becoming. When we stand under the stars and think of black holes, we're also thinking of time, of finality, of memory, of what it means to be erased and what it means to persist. Because there is something paradoxical about a black hole. It is, by definition, invisible, and yet we've seen it. Not directly, no, but we've seen the light that curves around it, the stars that dance near it, the waves that ripple from its collisions. We've seen its absence, and from that, inferred its presence. And isn't that true of love, of grief, of faith? We don't see them either, but we see what they bend, what they affect, what they orbit. Perhaps black holes are not the death of meaning, but the densest form of it. Perhaps they are where the universe keeps its most complicated feelings, the ones that can't be said out loud, the ones that need silence and time and pressure to become something else. Maybe when we say, can black holes delete the universe? What we're really asking is, can we be forgotten? Can we be undone? Can something so full truly become nothing? And the answer, as best we can tell, is no, not entirely. Because even if black holes swallow the light, they don't erase the story. They change it. They compress it. They make it harder to read, but not less real. In some ways, black holes are the universe's way of remembering without revealing, like a sealed journal, like a locked room filled with echoes. And maybe that's enough. Maybe not everything needs to be understood. Maybe not everything can be. But it can still be respected, still be wondered at, still be loved, in its darkness, in its mystery, in its refusal to give us all the answers. Because maybe the point of black holes isn't to explain them. Maybe it's to sit quietly with them, to acknowledge that there are places in the universe and in ourselves that resist language, and that those places are sacred. So the next time you look up at the night sky and think about the holes that might be hiding there, try not to see them as threats. See them as questions. Old ones, soft ones, the kind we carry with us through every version of time, the kind that don't close doors, but ask gently, what if this isn't the end? What if it's the pause between breaths? What if the universe in its own way is dreaming, and black holes are where it closes its eyes? Black holes live in space, yes, but they also live closer than that. They live in our stories, in our jokes, in our metaphors, in the way we describe a feeling, a moment, a kind of day. We say, I'm in a black hole lately. We say, that conversation was a black hole. I put something in, but nothing came back. We talk about scrolling through our phones as falling into an algorithmic black hole, about losing hours on the internet sucked into endless feeds, about binge-watching a show until we look up and find time itself has collapsed. Even children, long before they know what a singularity is, understand the phrase, it disappeared like it fell into a black hole. We don't just observe these objects from afar, we adopt them. We use them to name what otherwise feels unnameable. Loss, absence, obsession, disorientation, transformation. A black hole becomes a shorthand for emotional gravity, for events we can't undo, for the mysteries we don't know how to carry. And strangely, that makes them familiar, even comforting in a way. Because when you give something a name, even a dark one, you start to have power over it. You make it part of your story. It's no accident that black holes show up so often in fiction. In novels, films, games, songs, they're irresistible symbols, doorways to other worlds, machines of judgment, cosmic mysteries that force characters to confront who they really are. In Interstellar, the black hole isn't just a plot device. It's a test of love, of memory, of time's flexibility. The closer Cooper gets to it, the more distorted his experience becomes, and yet, it's love, not science, that gives him the thread back home, as if to say, the deepest gravity is not mass, but meaning. In Event Horizon, the black hole is horror, a literal portal to a hell dimension, a metaphor for madness, for curiosity gone too far. For what happens when we look into something we weren't meant to see? Even in Donnie Darko, the black hole isn't shown, but it's felt as a pocket of reality that loops, folds and resets, as if the universe itself is trying to fix something that went wrong. And that's the thing. We often imagine black holes as places where the universe does something unusual, where the rules flex, where reality twists itself into a new shape, because in daily life, we feel that too. We've all had moments where time moves strangely, where hours vanish or seconds stretch, where emotions bend our experience of reality. Grief, for example, it bends time, flattens space, pulls everything inward. You orbit around the absence, trying to make sense of it, and sometimes you fall in. Not forever, but long enough to feel the pressure of that gravity. Love can do it too, especially the kind that changes you, that pulls you past a point of no return, that makes you someone different than who you were before. In those moments, metaphors stop being decorations. They become survival tools, and black holes, for all their strangeness, help us talk about what it's like to lose control. We also find them in comedy. We laugh about how our socks vanish into black holes in the laundry machine, about how the office meeting spiraled into a productivity black hole, about how group chats, when silent for too long, seem to enter a black hole of awkwardness. The phrase carries a weight, but it's also playful. We use it to soften things, to make the overwhelming feel containable. There's something disarming about using the language of cosmic destruction to describe your lost car keys. Even children's shows make room for black holes, not as terrifying ends, but as whimsical plot twists, as portals, as lessons in what not to fly your spaceship too close to. In art, black holes become shape and texture, circles inside circles, swirling spirals, dark centers surrounded by light. They become visual metaphors for tension, for mystery, for collapse, and also for beauty. Because they are beautiful, not just scientifically, but aesthetically. Symmetrical, simple, powerful. They're elegant in their silence, in their refusal to shout. And there's another kind of beauty too. The way black holes represent things beyond our understanding and still invite us to try. They are in that way like love, or death, or growing up. Things that change us, even if we never fully grasp them. You can feel their pull, you can measure the light around them, you can map their effects, but the core, the singularity, stays hidden, sacred even, and that mirrors something human. We all have parts of ourselves we don't fully understand, memories we can't revisit, feelings we can't explain, past versions of us that collapsed into something new, and in that collapse created who we are now. Maybe that's why we use black holes to talk about depression, about trauma, about change, because these aren't just shadows, they're transformations. The thing about black holes is, once you cross a certain point you can't go back, and that's scary, but it's also true of life, childhood, first heartbreak, grief, becoming a parent, leaving home, falling in love, losing someone. Each one is an event horizon. You don't always notice when you cross it, but afterward, you're never quite the same. The black hole becomes, then, not just a metaphor for destruction, but for the unreturnable, and that gives it a kind of reverence, a quiet respect. We don't rush into black holes even in metaphor. We circle them, we name them, we learn to live near their edge. That's reflected in how we talk about creativity too. We say, "I'm stuck in a black hole of doubt." Or, "That project disappeared into a creative black hole," but also, "That idea came out of nowhere, like from a black hole." Sometimes the darkness gives something back, a new thought, a new version of yourself, a sense of clarity born from letting go. Because black holes, for all their gravity, don't just swallow. They reveal. They show us what light does under pressure. They show us how space curves when mass is concentrated. They show us what it means to be shaped by what we cannot see. Even the fact that black holes have entropy, that they store the information they swallow, has leaked into culture. We imagine them as vaults, as cosmic databases, as keepers of secrets. Some sci-fi writers have even proposed black holes as storage devices, the most efficient way to pack information into space. The ultimate USB stick, the universe's diary, and then there's the science fiction version of black holes, the ones we ride through, the ones we survive, the the ones that lead to other galaxies, other dimensions, other futures, that version is less likely to be real. But it feels real sometimes, because we need those metaphors. We need the idea that going through something impossible might lead somewhere meaningful, that the darkest tunnel might somehow curve back toward light. We need black holes to mean something, not just deletion, but redirection, not just collapse, but transition, and perhaps, this is the most human thing of all, we need to believe that even in our deepest silence we still matter, that even in our most invisible moments we still affect the world around us, that our gravity, our presence, is felt even when we're not seen. Black holes, after all, aren't dangerous because they attack. They don't hunt. They don't choose. They simply are. Mass so concentrated, time bends. Existence so dense, light can't leave. And yet the world moves around them. Light curves. Matter orbits. Stories unfold in their wake. That's how humans are too sometimes. We don't always shine. We don't always speak. But we shape things. With our gravity. With our silence. With our presence. In relationships. In communities. In culture. And maybe, just maybe, in the way we leave things behind. So the next time someone says, "I'm in a black hole," maybe we can hear that not as despair, but as process. A point past which something new might form. A boundary crossed. A moment so dense with feeling, it changes the curvature of life around it. And maybe, when we say it ourselves, we can remember black holes aren't endings. Not really. They are where the story folds, where everything we were becomes the core of something else, where light waits, where time lingers, where gravity listens, and where, somehow, even in the absence, there is still meaning. What if black holes aren't what we think they are? Not engines of destruction, not endings, not even boundaries, but portals. Not necessarily the kind that open with a flash of light and a cinematic hum, but quieter ones, slower, the kind you don't notice until you've already crossed through, the kind made of time and gravity, not metal and glass. What if? The phrase alone is its own kind of wormhole, a shortcut to curiosity, a gentle spiralling out into questions we aren't expected to answer, only to feel. Because once you start to ask what if about black holes, the ordinary rules loosen. You step across a threshold, like entering a dream. So let's do that. Let's dream softly about what might be. What if black holes are time machines, not just in the poetic sense, that they mark moments of irreversible change, but literally, mathematically, a route through time itself. Some solutions to Einstein's equations allow it. Inside a rotating black hole, a Kerr black hole, space-time doesn't just collapse, it swirls. It curves in on itself so tightly that some paths, in theory, could loop back in time. These are called closed time-like curves, loops in the fabric of time, in such a place you could follow a path that leads you to yourself, not in memory, in presence. It's not just wild, it's uncomfortable, because time, to us, feels sacred, linear, forward. We are born, we live, we remember, but we do not return. And yet, what if? What if time is more like a record than a river? What if it can be replayed with the right stylus? What if falling into a black hole at the right angle, at the right moment, spins you not to your doom, but into your own past? Would you watch yourself, silently, from behind the veil of gravity? Would you try to intervene? Or would the universe bend to preserve the timeline, no matter what? These are the kinds of questions that physicists whisper about. Not always in papers, but in cafes, in late-night messages, in chalk-scribbled corners of blackboards, where math gives way to wonder. Because maybe these closed loops exist, not as real places we could reach, but as artifacts of the equations, as reflections of possibility. Reminders that our most trusted models still hide riddles. And then there's the other side of the what-if coin, What if black holes lead out? Not just through time, but to other universes. Some theories suggest that every black hole might contain its own Big Bang, that a collapsing star in one universe could seed the creation of another, a universe where time begins anew, where the constants of physics shift, where perhaps another version of you, slightly different, stares up at slightly different stars. This is the multiverse hypothesis, dressed in gravitational collapse. It's speculative, of course, deeply, but it's not fantasy. Because the math, strange and beautiful as it is, doesn't forbid it. And in cosmology, sometimes that's enough. Not proof, but permission to wonder. So what if every black hole we see in our sky is a womb? What if each dark spot, silent and shrinking, holds inside it a moment of creation? And what if our own universe, the stars, the planets, this moment, all of it, began in the death of some black hole we will never see? A kind of cosmic reincarnation. In this view, death is not the end of the timeline, but a branch, a fork, a bud on the tree of existence. We wouldn't be the center. Just one bloom among many, a child of a star that collapsed in a higher cosmos, and maybe, far beyond our own, we've already given birth to others. If black holes do this, if they carry the seed of future universes, then we're surrounded by invisible beginnings, endings that aren't, stories we can't read but are still being written. Now let's turn the prism slightly. What if black holes aren't the exception, but the default? What if, at the end of everything, all matter collapses into black holes, every galaxy, every star, every atom, until all that remains are these dark cores, slowly evaporating. Over trillions upon trillions of years, they shrink, radiate, fade, and then silence. No more heat, no more stars, just a flat, empty stretch of time. This is the heat death scenario, a universe where entropy wins, where nothing interesting can ever happen again. But here's a paradox. If everything ends in black holes and black holes eventually evaporate, what's left? Some have speculated that the last black hole to vanish might in doing so reset something. A final flash, a quantum fluctuation, a new inflation. In this sense, the end becomes the beginning again. Not by design, not by intention, but because the universe is restless. Because even silence can't last forever. Now imagine this. What if black holes are conscious? Not intelligent in the human sense, but aware, alive, sentient in some alien way. They process information, they grow, they affect their environment, they respond to stimuli, swallowing, spinning, emitting. From an information theory perspective, they behave like computational systems. They take input, transform it, return output, even if it's just heat. And some have asked, if you build a large enough system that processes enough information, does it eventually become aware? Could a black hole, somewhere, wake up? Could it know? This isn't mainstream science, but it's also not pure fantasy, because the line between matter and mind is blurry. We still don't understand consciousness. We don't know where it lives, whether it's an emergent property of complexity or a fundamental fabric of the universe. So it's not unreasonable to ask, if you concentrate enough gravity, enough time, enough entropy, do you concentrate awareness? And if so, what would a black hole think? Would it remember what it had consumed? Would it dream of the stars that fed it? Would it know it was the last thing left in a dying universe? Or would it feel nothing at all? We don't know, we probably can't, but we can imagine. And sometimes, imagining is the most intimate form of science. Because every leap of theory begins with a what if, and then there are the paradoxes. So many. The information paradox, of course. If black holes evaporate, where does the information go? Does it leak out bit by bit encoded in Hawking radiation? Does it stay on the event horizon, as the holographic principle suggests? Or is it lost? That idea offends quantum theory, which says that information is never destroyed, and yet general relativity, equally precise, says that once past the event horizon, information can never return. So the paradox stands: two perfect theories and only one universe to explain. Physicists debate this, build models, propose resolutions. One says the information stays encoded on the boundary. Another says it re-emerges, scrambled but intact, in the radiation. Another, more radical, suggests that there are firewalls at the event horizon, burning sheets of quantum energy that destroy anything falling in. This would break general relativity. It would mean space isn't smooth, but fractured. It would mean the fabric of reality isn't woven, but scarred. Again, we don't know, and perhaps we never will. Because to truly answer these questions, we'd have to do something that seems impossible. Fall in. Not just in theory, but in person. Observe the horizon, pass it, see what lies beyond, and that, for now, is forbidden. So we imagine. We write stories. We build simulations. We create analogues in labs, acoustic black holes, where sound, not light, cannot escape. We build detectors, launch satellites, watch the stars. We listen for whispers of possibility, because black holes sit at the edge of knowledge and they call to us, not with sound, but with silence, not with light, but with gravity. They are the universe's question mark, its softest paradox, and maybe its oldest dream. Because what if black holes aren't anomalies? What if they're seeds? What if every collapse is just a folding in, a holding of potential? What if every loss is a beginning disguised as an end? In the end, we can't know, but we can wonder, and sometimes that's enough. Sometimes the what if is the answer. Maybe you're still awake, or maybe you're somewhere in between, not quite dreaming, not quite here, floating in that quiet space where thoughts stretch out and time slows. That's where black holes live too, in a way, at the boundary, at the place where questions deepen and answers soften, where the known curves gently into the unknown. So let's stay here a little longer, not to summarize exactly, but to drift, to let all of this, the science, the stories, the speculations, settle like dust in a ray of starlight. We began with gravity, with a force so familiar we hardly notice it. It keeps our feet on the ground. It guides the planets in their orbits. It's the quiet rhythm of the cosmos. But taken far enough, gravity becomes something else. Not just a pull, but a plunge, a folding, a surrender. That's what a black hole is. Gravity without limit. Matter collapsed into silence. The music of a star brought to a single, low note, too deep to hear, too heavy to escape. And in that silence, something extraordinary happens. The rules flicker. Time stretches. Space curves. Information tangles. Physics hums a stranger tune. And maybe that's why black holes feel so mythic. Not just because they're powerful, but because they break the spell of certainty. They remind us that even our best explanations still have edges, borders, horizons. We talked about their formation, how stars die, how light can be trapped, how space can be sculpted by mass. We followed the spiral inward, past the event horizon, toward a place we can't describe, a place without place, a singularity. And yet, we didn't stop there. We asked, what does it feel like to fall in? Not just physically, but emotionally, existentially. Because the idea of a black hole isn't just astrophysics. It's metaphor, it's memory, it's fear and beauty braided together. We looked at how cultures spoke of cosmic centers, how myth and language echoed this hunger for the hidden, how stories from every age have pointed toward the sky and whispered of the unseeable. We stepped into science again, the entropy, the holograms, the firewalls, the paradoxes that tie knots in our logic, the dreams of wormholes and white holes, the delicate tightrope between general relativity and quantum mechanics, each flawless, yet somehow at odds. We traced the history, from Newton to Michel to Einstein to Hawking, from speculation to observation, from chalkboards to telescopes to the glowing ring captured in 2019, the shadow of a black hole framed in light. We asked the big questions, not just what is it, but what does it mean? Can information be lost? Can time be looped? Can endings give birth to beginnings? And even closer to home, we asked, why do we talk about black holes when we feel overwhelmed? Why do we use them to describe grief, obsession, burnout, love? Maybe because they hold everything we can't explain. Maybe because they are the explanation. A black hole is more than an object. It's a gesture. It's the universe shrugging its shoulders and saying, some things you just have to feel. And maybe that's not a failure. Maybe that's the point, that not everything needs to be named to be real. That mystery isn't the opposite of understanding. It's part of it. Because when you think about it, we all have singularities inside us. Moments of collapse, points of no return. Times when we were changed so completely we couldn't go back, even if we wanted to. A heartbreak, a death, a realization, a moment of awe so deep it bent your sense of self. You crossed a horizon, and afterward you were not the same. That's what black holes teach us. That change is not linear. That time is not always smooth. That identity can be stretched, compressed, reshaped, and still hold. They teach us that silence has weight, that absence can speak, that the most powerful thing in the universe doesn't need to shout. It just is, still, dense, unseen, but undeniable. And even though we can't peer past the event horizon, we can measure what it does. We can see its effect. We can feel the curve. And maybe that's enough. Maybe that's all we ever do, with each other too. We don't always see each other's singularities, but we feel the gravity. We see the orbit of behavior, the tilt of emotion. We sense when someone has been changed by something deep, something private, something unnamed, and we stay near, we circle, because in the end, black holes aren't just about destruction. They're about boundaries, about intimacy, about what happens when you draw so much of yourself inward, you vanish from view, but not from connection. Because even hidden, you have gravity. Even silent, you speak. And sometimes the most honest thing we can say is simply, I don't know what's in there, but I'm here. I feel it. And black holes say that too, in their own way. They don't explain themselves, they don't perform, they just curve space, bend time, hold mystery, and that is enough. And maybe, just maybe, that's a message for us. To be less afraid of not knowing, to honour the quiet, to let ourselves be gravitational, not because we shine, but because we are. So let's return to that first metaphor, the one we never quite finished. Is a black hole a hole? A wound? A well? A mirror? Maybe it's all of them. Maybe a black hole is where the universe keeps its dreams, the ones too big to be spoken, too dense to be unfolded, too soft to be anything but held in silence. Maybe the universe, in its own way, has a heart. And maybe that heart is dark, not because it's empty, but because it holds everything, compressed, waiting, infinite, just like us. So wherever you are and however you're feeling, maybe this is your invitation, to let some questions remain open, to let wonder do its work, to trust that even in the places you can't see, there is structure, there is meaning, there is beauty, and black holes are proof. They are real, they are strange, they are serene, they are the edge of what we know, and the beginning of everything we don't. So rest, fellow traveller. Let the metaphors settle, let the light bend gently around you, and remember, even in darkness you're not lost. You're still part of the story, still orbiting something beautiful, still here, still whole, still, becoming. So, where are you now? Still lying there, eyes closed maybe open just a little. What time is it? Midnight? 3 a.m? Or something stranger? A time between names? Maybe time has lost its shape a bit. Maybe you've floated beyond clocks and calendars and into something quieter, something softer. If so, you're exactly where you're meant to be. Because that's where black holes lead us, in the end. Not just to the edge of space, but to the center of feeling. To the rhythm behind the rhythm. To the weight behind the silence. Maybe you didn't fall asleep. That's okay. Maybe you were just resting, or remembering, or letting your thoughts spin gently around tonight's quiet question. Can black holes delete the universe? We still don't know, and maybe we never will. But we do know this: even in a world full of noise, there is still space for stillness, for wondering, for stories that don't need a tidy ending. If this gave you peace, even for a moment, I'm grateful. If it helped loosen the tight threads of your day, if it opened up just a little room in your mind for stillness, thank you for letting it. That's all we're doing here, really. Not answering everything, just keeping the stars company. So sleep well, fellow traveller, wherever and whenever you are. And if you find yourself dreaming of light, or falling, or time turned gently inside out, maybe that's just the universe remembering you back. Good night.